Hello everyone and welcome to another edition of Hunt's Handy Hints. So you thought you'd hear the last of me? I'm afraid not. You lucky people have got me coming through your TVs, your computers and your mobile. So today we are looking at probability. So this is something we've done in your books about a month ago. So do double check back through your notes, but it is worth going over it again today. So you may remember these probability trees that we've done. So we need to start out by filling in the probabilities. So there's some important information in my question here. So number one, that there are 4 red counters and 3 blue counters. So from here we can write in our probabilities. There are 4 out of 7 reds, because adding these together there must be 7 counters in the bag. And then the blue must be 3 out of 7. Now, if I continue reading, a counter is taken and it's colour noted and returned. Now, this returned is really important. It means that the probabilities do not change. They can stay the same all the way through. So, red is still 4 out of 7, blue still 3 out of 7, and so on. Now, before even reading the main questions, I'm going to start writing in my outcomes. So, for this first one, it's a red and a red. Now, I'm going to make a real point of writing and. Next one, red and a blue. Blue and red. And finally, blue and blue. So now we've got these outcomes, we can start writing in our probabilities. So for red and red, you may recall that and is a times when we're talking about probability. That is a really important thing to remember. So what you do is 4/7 times 4/7. When we times in fractions, we just times the numerators and times the denominators. So 16 over 49. Don't try and simplify it, number one, because you can't, and number two, you don't need to. Next, red and a blue, that's going to be 12 out of 49. And then for blue and red, we're going to get 12 out of 49. And finally, 9 out of 49. So now we have a completed probability tree with all our outcomes. Now it's worth noting that if I add all these outcomes together, I get 49 out of 49, which is exactly what we want because all of probability adds up to a whole. Likewise, on our branches, these, where they join, should add up to a whole also. Now, let's start answering our questions. So the probability of 2 reds. Now, this is quite nice because actually we've already worked it out. 16 over 49. Now, this one becomes a little trickier. You have to be careful about what it's asking. What is the probability of at least 1 blue? Well, we have several options for this. So, at least 1 blue. This could have been a red and a blue. Or a blue and a red, or a blue and blue. Because it says at least 1 blue, we can include the 2 blues. If it says what's the probability of 1 blue, then we just have these. Now, or in probability, this is an add. So we use the red and the blue, red and blue, which is 12 over 49. Blue and red, also 12 over 49. And blue, which is 9 over 49. And you add those together. So 24, 31 over 49. Sorry, 33. Great start. Now, there is another method you could have used. You could have thought, what's the probability of at least 1 blue? Well, that's the opposite of having 2 reds. So you could have had a whole, take away the 16 over 49, would have given you the same answer. But this is probably the most straightforward, although maybe slightly longer. Now, tomorrow we will be looking when the counter isn't returned, where these probabilities may change. So for today, practice this and also have a look at frequency trees. Probability trees, sorry. That task has been set on Heggerty Maths also, but it is a little more straightforward. That's it from me. You've been listening to Hunt's Handy Hints. Until next time.